that condition, if you think about it, that if two nodes are merged, that means they are very heavily trading with each other, right? That's the way I have used this merging algorithm. And you can see this. So for example, on the real life data, I showed you about 15,000 transactions and so on. I ran the algorithm with k equal to 10, kt equal to 4. I got 3 sets of potential colluders. Each one is a set of potential colluders. That's not the interesting part. The interesting part is I ran the algorithm with another parameter setting k equal to 50, kt equal to 45. I got now only one set. I ran it k equal to 60, kt equal to 55. Again, I got only one set. Still, there is not interesting part. The interesting part is that the nodes in blue are occurring in all the outputs. No matter what I set the parameters for k and kt values, the 4 are always occurring together. Okay, that's the interesting part. That means looking at thinking of the algorithm execution as some kind of perspective. From different perspective, these people are coming together as colluders, right? So more runs I have of this algorithm, more evidence I have against these 4 people. Not only this one algorithm, but I showed you a list of other algorithms I have. Each one of those also can be run with multiple parameter settings. And again, these 4, from no matter which graph clustering algorithm you use, these 4 people are coming together. Others are sort of random noise. Like 1049, sometimes it comes, sometimes it doesn't come, and so on. So what we did was we analyzed. So I'll forget about this complexity and all that, but you can. It's a very efficient algorithm. So we use many different algorithms, as you can see these 3 boxes for algorithm, and each one gave us a set of collision sets, which we call candidate collision sets, and we use Dempster-Shafer theory of evidence combination to actually think of each algorithm output as a kind of evidence against that particular subset. So for those 4 people, since they are coming out again and again in different outputs, more evidence was accumulating, and we systematically mapped this problem to the evidence combination mechanism. I don't have time to tell you about it, but you should read it. It's a very important statistical technique, again from the 70s, but now of course there are a lot of other evidence combination techniques, and so I use the evidence combination technique to filter out the outputs of the multiple algorithms, and finally said that, look, these are the 4 people, okay, against whom there is multiple evidence, and the belief that they are colluders. You can see I have calculated it using the Dempster-Shafer theory. It's very high belief against these 4 people, and very little belief against any other subset. So that's how formally we can now say. It's not like we just observe the output and say, oh, that must be, those are the guilty people. No, we are trying to combine it very much more systematically to actually give confidence measure to our output or our accusation, right? So that's how. So here is one case study. I mean, you can. So here there are about 830,000 trades among 1,037 people, and we applied this mechanism, all this stuff, and we found there is a group of 10 people, okay, who were colluding with each other. This is actually verified by the stock exchange. They were quite happy, and this is actually a system in execution in one of the large government agencies which monitors stock market. So there are other methods. I will skip all this and I will stay here for a minute. I just want to say 1 or 2 other things. That this is an unsupervised method. That is very important for you to note, that we had no data about past instances. Okay, and also one of the things that you should consider is that the strategy need not be circular, A to B, B to C, C to D, D to E, no, and E back to A. It need not be. We have nowhere we have made that assumption. If you examine this algorithm carefully or read the paper, nowhere we have said that it has to be circular, it's like a Hamiltonian circuit. No, it's not like that. Any random strategy they could, so they can spend their time devising clever strategies thinking that there is nobody smarter than them, but the algorithm is immune to the actual strategy used for trading. Okay, so that's, and there are other things, and I have a paper and a tutorial in one of the conference sessions. So maybe let me stop here. There are other kinds of frauds that I'm working on in the stock market itself. Now what has happened is crooked people have got technology on their side, algorithmic trading, right? You can place 1 million orders in 1 second on a stock exchange, modify them, cancel them, and again millions per second. So now it's not like human beings are doing this. Now machines are doing the fraud on behalf of human beings. So now we really have to ramp up our game, and we should really be able to detect new kinds of frauds that the algorithmic trading is enabling. That's one of the projects I did recently for a government agency, and it's running, and I hope to see some bad people behind the bars soon. Okay, so don't be a bad person. Okay, that's the moment. Okay, thank you very much. Any questions?
So, I mean, just want to ask, like, so for example, this approach which you described, basically this is again like, whoever is shortlisted, so to speak, in the,
Yes.
from the collusion, they will then be examined.
Yes.
So you cannot make a case just on this.
No, absolutely, that's a very important point. Absolutely not. Okay, I don't want rich people running behind me with a gun, saying that how could you achieve it? No, that's all done by the real investigators. They do examine a lot of other evidence, banking records, this, that, all that, lot of other stuff. Then they make a case. But we point fingers, say, look here, these might be the bad guys. So it's genuine detection, and from detection to actual litigation or punishment, there is a long gap. That's what I was trying to say, that there is a lot of human expertise there. Okay, and
So, I was just going to, like, for example, a system wherein which detects a collusion happening and maybe blocks it is not going to work. Right? I mean, or should not, or will face legal handle because it's going to.
yeah, that's true. There are legal issues and also reliability issues. I mean, it's not going to be possible to claim just because we detect them as colluders. It's not possible to prove that they are actually colluders. You have to prove that they made money in this. That is first criteria, right? So until all the positions are cleared and so on, we cannot really say whether they made money or not. So it's very difficult. Yeah. So in real time we cannot. Sorry. No, I'm.
So thank you very much. I request Dr. Shah to present him with a token of appreciation.